So in summary, what we've got is we've got chemical energy, which is contained in the batteries, and that chemical energy is turned into electrical energy, but that can only actually work when I have a complete circuit. So what's actually happening here is these electrons there's a pressure on them, they're trying to be pushed them round, but you can't actually get anything happening, you can't get any movement until we push the switch. As soon as we have the switch, that allows the movement of those electrons, and that's what gives me my light. And that's what gives me my light. We're going to look at the very nature of electricity. What is electricity? How does it actually work? Now, if I press the button, right, so just one moment, if I press the switch, what's going to happen?
It's going to work.
What's going to happen?
It's going to turn on.
It's going to turn on?
No.
Wrong. You've got no idea what's going to happen.
You've got to get the right wires to...
It's got to be plus to minus.
Oh, yeah, it's got to be plus to minus.
And then it's
Probably red.
Okay.
Red.
What we've actually got here then is it's got to be plus to minus. When I press the button now, look what happens. Well, hey, the light goes on. Why? What's moving? Something's happening.
Electrons.
Excellent. Those electrons are moving. I tell you, I've taught you.
So what's that bit on wood?
Those electrons are moving. Doesn't matter at the moment. Those electrons are moving around the circuit when I actually close that. So what must be happening? There must be a pressure on those electrons. They must be trying
And
to
if
push.
it's the wrong way round, the electrons, they bump into each other and it stops it.
And repel.
One's pushing one way, one's pushing the other way, and it stops it. Excellent.
They're
Now,
both going the
what's
same way.
happening as I go around this circuit then, those electrons are actually able to move, and they go around the circuit,
Without hitting anything.
and
They go the same way.
Well, where do they get their energy from to move?
The battery.
Excellent. What kind of energy is that? Begins with C.
Chemical.
C-H? Who's a chemical?
Me.
You're a
Carbon
genius. I thought it was-
dioxide.
You said that without moving your lips, Callum. Fantastic, mate. I'll give you an extra bonus for that one.
Okay.
Right, so what it's doing is actually chemical energy is being turned into electrical energy, and the electrical energy is actually travelling around, and it's being turned into what kind of energy?
Light.
Light energy and
Heat.
heat. Which one's wasted?
Heat.
Heat's wasted and the light's not wasted.
You
So
don't
that's what
need
electrons. So if I actually disconnect that, there must be those electrons.
connect them
There's
together, it should
pressure in those electrons. Just wait, because that's your own experiment. There's pressure in those electrons to move, but they're not going anywhere. Why not?
Because they can't.
Because they can't. They've got nowhere to go. Which leads us on to Van de Graaff generator, an absolute classic. Every physics department needs one, and no lesson on electricity can ever take place without a Van de Graaff. Very, very reliable when you've got a cold, dry day, but on warm and damper days we can sometimes get quite a lot of leakage of charge from the ball, and hence it refuses to charge. If that happens, what you need to do is get yourself a hairdryer, and with the hairdryer keep drying the air around the ball, even warm the ball up somewhat. Okay, switching the Van de Graaff on, and they're producing sparks. One thing about Van de Graaffs is the class can get very, very excited and very noisy, and a quick way of actually giving them a signal to actually be quiet again is to actually use the discharge ball and tap 3 times, that being the signal, time to be quiet, and we can actually move on. A nice demonstration is using foil casings from mince pies, etc. Aluminium foil. Place a pile on like that, switch your Van de Graaff on. Got an interesting demonstration is, well, I'm using the ion wind. Now I've got a rather cobbled together piece here, but basically what we're using is we're using 2 or possibly 4 pieces of wire which are actually connected up, actually bent, so that we have a kind of a weather vane type structure and when we switch it on, we should see the movement caused by the ion wind. Using a metallized ball, such as this one, is a very good way of showing charge and discharge of the Van de Graaff. And as I switch the Van de Graaff on, we should see the attraction and repulsion of the ball. Okay, here we have a Van de Graaff generator. Now, believe it or not, it's a very similar thing. It's a very similar thing to the battery, because what it does, it actually, but this one moves electrons. So it's moving electrons from the bottom, goes up the belt, and it dumps those electrons on the top. Okay. Now, like the battery, when it doesn't have a circuit, those electrons can't do anything. They can't go anywhere until you actually give them somewhere that they can go. So, if I was to switch this on, at the moment those electrons are nicely building up on the dome. Away from it for now. And if I actually give them somewhere to go, look what happens.
So use the pinball stuff again.
Okay, that's actually giving them somewhere to go. What's that the same as? Something you've seen with excellent lightning. And so what that is, that's like a thundercloud. And that's all thunderclouds are. Thunderclouds happen on what kind of days? Cold days, hot days?
Hot.
Hot days. Little clouds, big clouds?
Big.
Big clouds. And what happens is there's lots and lots of rubbing going on within the molecules of the clouds. And so what happens is you get a distribution of electrons. Electrons are moved from one place to another, and then they sit there. They can't do anything until finally they actually find there's a way to there's somewhere for them to go, and that's when you get the zap and the spark. So that's what lightning is. What's thunder?
Sound.
It's the sound of what happening.
Rumbling.
Yeah, it is a rumbling sound.
Oh,
Sound of what
the
happening.
clouds rubbing us, don't they?
It's not.
Yeah.
They're just air.
What are you here now?
Box. No, like it's gas. When you flip the
No.
cooker on. When you
stop
try to
guessing?
Excellent. It is just like when you put a cooker on. That's called a piezoelectric effect. The switch which actually switches the cooker on. That's brilliant. But what's actually happening here is that the sparks are causing that crack noise, and that crack noise is to do with the air
If you make
expanding.
gas nest now, what would happen was you'll
Can you listen to me, Callum? Because what's actually happening there is that that crack, it heats the gas up so much it expands, and if it expands very rapidly, expands and then contracts again, what do you hear?
Noise.
Sound. And so the sound that you hear for thunder is actually the heat from the lightning causing the air to expand and then contract again. Now, what we're going to do now is we're going to see, can we turn somebody into a battery?
James.
So what I need is I need a volunteer.
James.
I need somebody who's got good hair that will actually stand up on end.
James.
About there, okay?
Sam, does that hurt me?
Okay,
Yeah.
come into the side.
Can you hear that from here?
Oh!